Hello all. I have one last wave experiment I'd like to show you. This one was a bit of a puzzler. Now you know that light is made of waves. We did the double slit experiment. You should be well versed in that. Light is clearly made of waves and not particles. So this one was a little hard to explain. So here's the idea of the experiment. And this one also has been performed for more than 100 years. And we always get the same result. I have a negatively charged zinc plate. So I have electrons in excess scattered all over the plate. And you can see that because I have an electroscope here that shows that there is a charge on this zinc plate. The zinc plate is isolated, so it's an insulated zinc plate. Freshly sanded zinc surface, so it's nice and smooth. No oxides on it. That's important. And I turn on some bright lights. Now, we know, because light is made of a wave, that these waves are going to come down and hit the surface. And because of the nature of waves, sometimes you're going to have constructive interference. Not all the time, but you don't need it all the time. If you have some constructive interference, that should boot off an electron. As a matter of fact, with enough bright light, it should boot off all the electrons, right? Well, the thing is, that never happens. So you turn on more lights, you add more lights, more waves coming in. Doesn't matter. No electrons get booted off. The electroscope stays perfectly charged. So what's going on here? Well, if you change up the experiment and just get a UV, an ultraviolet light. Just give me an ultraviolet light source. Now, what's that look like? Those are very, very short waves of light. Very short waves. And the thing is, even if I have very dim ultraviolet light, it starts to boot off the electrons, and the electroscope falls down and shows itself to no longer be charged. So what's the deal? Why does ultraviolet light kick off electrons and bright light does not kick off electrons? Well, it gets to a different understanding. And what the results of this experiment simply say is that light must be made of bullets, particles, and that the bright lights, the bullets are too weak to dislodge the electrons. But we know ultraviolet light being stronger, the bullets from ultraviolet light, whoa, those bullets from ultraviolet light are seriously strong. And they come in, and it's always a one-to-one interaction. Those bullets, called photons, eject the electrons. So this experiment is known as the Photoelectric experiment. And the upshot is that it proves light is made of particles, and that light can't be made of waves. We've done this experiment over and over. We're solid on it. We know exactly what it proves. The problem is that it proves the exact opposite of the double slit experiment, that also has been done and well understood forever. So, welcome to the world of quantum physics. Quantum physics completely violates our logic. It has forever. We understand it very well, but it does violate our logic. So we have to come up with a new logic to deal with this. And that we will do. We have to come up with a different form of mathematics to deal with this. That we will do. But fundamentally, you have two experiments that say exactly opposite things. I want you to take a look at a video I'm posting in Schoology on that, and that you will find very, very interesting. So take a look at the Dr. Quantum video, and yeah, and make sure you're sitting down when you watch it. This is that place I told you we were getting to in physics, and here we are. We're going to spend the next month or so working out the mathematics of this, which is really very simple. But it gets to remarkably interesting places. And we have verified this over and over again. We know what we're talking about. We know it violates our logic completely. But this is real, which means that whatever we're using for logic must not be completely solid. So we have a lot of really interesting physics to do, some fascinating videos to watch, and I hope you stay with me because this is the good ride. Thank you.